Mestex has been in the business of producing cooling and heating solutions for commercial and industrial buildings for over 40 years. One of the products that is produced in our Mestex Dallas facility is a line of evaporative cooling systems. Within that product line is a special system type referred to as an indirect evaporative cooling system. And one of the best applications for that type of system is to cool IT environments. The importance of the IT environment can be seen every time a commercial airliner lands. If you look around at your fellow passengers, you will notice that the first thing most of them will do is to pick up their portable phones and start checking messages and voicemails. Portable phones have even become fashion statements, as you can see in this photo. In fact, the use of mobile phones has exploded over the last decade. This chart shows that even before the Apple iPhone and the various Google Android phones hit the market, there was already a steep upward growth curve in mobile phone subscriptions, with half of the world population using some form of mobile phone communication. Of course, mobile phones are not the only devices that drive the digital information demand curve. Games, email, streaming video, digital television, and a host of other digital devices are constantly creating or consuming information and spurring a tenfold growth in the number of bytes transmitted or stored over just the last 5 years. Although there are many types of digital devices, they ultimately have one thing in common. The information passes through a computer server similar to the one in the upper right of this picture. The electrical power consumed by one of these devices is roughly equivalent to the power consumed by a 42-inch plasma television. And then the industry crams as many of those servers into a cabinet, sometimes called a 42U rack, as they possibly can, making for power densities that become hard to imagine. But where you find one rack, you will often find dozens of racks. This photo shows what is basically a big warehouse filled with racks and power supplies, and suddenly you have a data center. This data center, built by Cisco, consumes roughly the same power as 20,000 42-inch plasma televisions, or enough energy to operate the air conditioning for 250 Texas homes in the middle of the summer. And data centers like this are popping up all over the world. Interestingly though, not all of the power that goes into a data center is actually used by the servers. In fact, on average, only about 36% of the electrical energy is consumed by the computer equipment. The rest of the electrical energy goes into things like backup power supplies, the lights in the building, and the biggest part goes into the building cooling system. The reason that the cooling system power consumption is so large is that servers generate heat. Basically, all of the energy that goes into a server for processing information ends up being converted to sensible heat. So even though the servers represent only 36% of the energy consumed, they represent over 70% of the heat generated in a data center building. And that heat load is growing with the increasing server densities that are necessary to meet the rapidly growing demand for digital information transfer. The numbers on this chart should simply astonish most people who are more familiar with conventional HVAC cooling requirements. While a typical commercial office building might have cooling requirements of 10 or 20 watts per square foot, you can see that some IT applications have cooling requirements approaching 10,000 watts per square foot of equipment. Even if you spread the equipment out over a warehouse-sized space, it is obvious that the cooling load is enormous. And this is the result. This new data center is going to have so many very large pieces of packaged rooftop equipment that there is barely any need for roof at all, and the power consumption will be huge. Even if some of these units may be offline at any particular time, the local electric utility must plan to provide sufficient service from at least 2 independent points, by the way, to meet the total demand of the building. That could mean 50, 100, 200 megawatts of demand load on their grid. From an environmental point of view, This huge demand for electrical power is going to be generated almost half by a relatively dirty fuel source, coal. While coal-fired plants can be operated cleanly, in the U.S. at least, the cost of cleaning up the emissions from a coal plant can be so high that the plant operator might choose to do what was done to the plant in the background. Simply shut it down, pushing the demand onto other plants and putting more stress on the grid that remains. But we have a way to help offset some of that problem, using a technology that is sometimes identified by the less than complimentary term, swamp cooler. Swamp coolers are actually evaporative coolers, and the concept is quite simple. If you take warm air and pass it through a porous pad that is soaked with water, you can get much cooler air out the other side. Water has a large capacity for absorbing heat as it transitions from liquid to vapor, and that is basically what is occurring. The warm outside air provides the energy to cause the transition and gives up large amounts of heat in the process. This is nothing new. Archaeologists have discovered hieroglyphics that showed ancient Egyptian slaves cooling their masters by waving fans over water-soaked reeds, and ancient homes cooled by hanging wet fabric in their window openings that would provide cooling when the wind was blowing from the right direction. Even that great inventive mind of Leonardo da Vinci used one of his designs to provide cooling for the bedroom of the wife of one of his clients. I suppose in typical flashy Italian style, Leonardo had to create something a bit more elaborate to show off for this woman, and thus this contraption would scoop water out of the cistern below and then dump it across a fabric pad mounted in the bedroom window. But no matter how it was done, the end result was the same. The building and the contents of the building were cooler, and the same idea can be used to cool those thousands of servers without ever needing chillers or DX equipment. The reason this is now a viable alternative to conventional cooling solutions is that the world of server design has changed. Server manufacturers publish data showing that their servers work just fine with inlet temperatures of 90 degrees F and even higher for the newest state-of-the-art designs, and relative humidities from 10% to 90%. But as we move into today's world and look at the application for evaporative cooling in data centers and server rooms, we encounter a term that sounds more like the sound a child would make when it smells something bad: PUE. This is actually an acronym, PUE, and it stands for Power Utilization Effectiveness. This is a measure of the total electrical demand of the data building divided by the electrical demand of the IT equipment itself. It is a measure of how efficiently the data center operates at full load, and the average around the U.S. is about 2.5. The building uses 2.5 times the energy of the IT equipment that is installed in it, which implies quite a bit of waste. Looked at another way, you can see that the servers themselves are only a small part of the total energy used by the building, with conventional HVAC cooling making up the bulk of the building energy demand. But if you use the Mestex Aztec indirect direct evaporative cooling system combined with hot aisle containment, a fancy way of saying you need to capture the heat off the back of the server rack and get rid of it instead of recirculating it, then you can change the PUE picture significantly without impacting the operation or reliability of the servers. Now, the amount of energy required for HVAC drops dramatically, and the whole PUE number shifts to something more like 1.5 or even lower. The data center operator can either reduce his overall building demand and save capital and operational costs, or shift more of the available electrical energy into the servers and increase his data processing capacity by more than double from the same size building. Either way, the owner wins: lower capital costs or more revenue producing servers from the same amount of total power. The product that can make that kind of difference is our Aztec ASC product line. In addition to the basic characteristics such as stainless steel evaporative sections and welded floors and drain pans, This line of products includes a number of features that make it well suited to data center applications. In particular, the integral DDC controls with monitoring and remote access allow the data center personnel to focus on the server side of the operation and the facilities team to focus on the HVAC equipment, even if they are not physically located at the site. The FiberDeck evaporative media is a glass fiber-based media that is flame and fire resistant when it dries out. Since there will be times of the year when evaporative cooling is not needed and there is no water flow, this is an important feature. The edge coating also adds durability to the media for less frequent maintenance, and the primary media is protected by a cleanable pre-filter. This can be particularly important in climates with lots of natural contaminants such as cottonwood seeds. Just to give you an idea of what an Aztec ASC can do for you, here are some rule of thumb electrical load figures for an Aztec indirect evaporative cooling unit versus a 10.5 EER air-cooled rooftop unit and a very efficient air-cooled chiller. Remember that 1 ton of cooling equals 3.51 kW of heat rejection, or about 12 servers operating at actual load, not nameplate. Another way to evaluate the Aztec ASC product is to see how it would perform in a typical U.S. city. The worst case scenario here, Austin, Texas, still would provide server inlet temperatures that are well within even the more stringent ASHRAE 9.9 guidelines. So the bottom line is that if you want to reduce your PUE, reduce your capital expense, or reduce your operating expense, and do so with cooling equipment that can still provide server inlet temperatures that meet most criteria, then you should seriously consider the Aztec ASC from the Mestex division of Mestex. Visit our website for more information and a point of contact at the Dallas facility.